In this video, I'm going to go over horizontal and vertical lines, what they look like as a graph, and what their equation looks like. So first of all, let's start with a horizontal line as a graph. So I'm going to draw here a horizontal line. Horizontal is flat like the horizon. And with this horizontal line, what we can see, if we think of the points on here, now there's infinitely many points across there, but I'm going to bold some in that are on the grid lines. Just pick a few random ones here. Now, this one here is the order pair -3, 3. So the x value is -3, the y value is 3. This one is the order pair 1, 3. And this one on the right here is the order pair 6, 3. As we go through there, we notice that with all of those, the y value is staying consistent at 3. The x value is different, and if I pulled in more order pairs, the y value would stay the same. We can think of the y value as how far up or down we've gone off the x-axis. If we have a horizontal line that's running parallel with the x-axis, every point on that line has gone the same distance from the x-axis. And so every order pair on the line is going to have the same y value. In this case, it has a y value of 3. The equation of this line, when we're working with lines with these two-dimensional graphs, usually they have two variables, both an x and a y. But with a horizontal line, the equation actually ends up only having one variable, and it's y equal to 3. Basically, the equation sets the y value, and the x value is independent and can just go over all the real numbers. So what is fixed is the y value, and the x value covers all real numbers. In that way, the x and y don't live in relationship so much as they usually do when we have both an x and y in the equation. The y is fixed, and the x is free to roam, is a way you can think of it. So we can, when we look at vertical lines, see something very similar, but it's going to be the x that is stuck. Let's say I have this vertical line, and I bold in a few points here, just arbitrarily. Well, this point is going to have the order pair 5, is going to correspond to the order pair 5, 4. This one's going to correspond to the order pair 5, -1. This bottom one here is going to correspond to 5, -6. So with this, we can see as we vary up and down the line, the x value is now held steady, and it's the y value that is free to roam about and cover all of the real numbers. So in this case, our equation for this line will be x equal to 5. So with vertical lines, the x value is fixed. The y value covers all real numbers, and that's really what creates the vertical shape, or the vertical tendency, because x is constant on that vertical trajectory. So what that means in the context of two-dimensional equations, or equations in two variables, is if you're given an equation that only has one variable in it, it's going to be either a horizontal or a vertical line, and then it's just up to you to remember which one it is. And I think thinking through, like if x equals 5, that means x is going to be 5 in every order pair on that line. So if you create 3 or 4 order pairs with an x of 5, you can convince yourself that it's going to be a vertical line. On the other side of the fence, if you have the equation y equals 6, if you think, well, that means the y value for every order pair on that line is going to be a 6, you can make up several order pairs and eventually convince yourself that that is a horizontal line. But you're going to have to come up with a way to convince yourself of that to keep them straight. So let's say we have this equation here, and it says graph 2x equal to 3x minus 4. Now, when you're given these equations with one variable, they're not always going to be solved down for that variable, in which case you just need to solve the equation for that variable. So I would start by subtracting 3x from both sides. That's going to give me a -x equal to a -4. And then I need to divide off that -1. So I get x equal to 4. Okay? So if I think x equal to 4, that's going to be out here. But that's just one order pair with x equal to 4. What's another order pair that has x equal to 4? Well, that's going to be anything on this vertical trajectory. Those would be where my x equal to 4s are. So I can go ahead and draw that line in. It's not a long process that convinces you or guides you to the right answer on these. You just have to really remember what's going on with these equations with one variable. Go ahead and give some of them a try and see how you fare.